Okay, hello and welcome to another video with Seeduino Xiao programming. So in this video I'm gonna walk you through some programming techniques and examples to help speed up your programming projects on the Seeduino Xiao. We're going to start by connecting some sensors and exercising different peripherals on the microcontroller. As you see in my video, I have my Seeduino here, and I have the expansion board. I connected LiPo battery because this will allow me to be able to use the Seeduino without the USB cable. It will power my system and it is rechargeable. The system, the expansion board actually does support a rechargeable battery, and it will have also the option to turn off and on that power in case you have to walk with that battery connected. This LED also, the green one here, is used to tell you the status of the battery. So if the battery is charging, it's green. If it's off, it means the battery is done charging. And if the battery is not connected, it will be blinking to let you know that the board is powered through the USB cable. Good. So also I connected some kind of joystick that has dual potentiometer for X and Y axis. I'm going to use that as an analog input sensor. I have power connected from this connector. I have the ground and plus connected, and on pin 6, which is GPIO 6, I'm using that pin here to receive back the analog value or signal from that potentiometer. So to do that, I am going to walk you through the code, and let's go. In this diagram here, it shows you the two ground and power signal that I'm using, and the pin 6 here that's multiplexed. I guess it can be used for different as a different inputs types, and right now I'm using it as analog in my code that we will work with. Again, here is the LiPo battery 3.7 connected, and this here shows you the LED and the power on and off switch. So I'm using again Visual Studio Code, and I am starting a new project. I called it, let's see here, this is the actual project I'm using, Seeduino Programming 101. Seeduino Programming 101. And you have the main.cpp for the source file that we will use. I always start with adding a comment on top of the file with naming and date and some type of information of what this file will have. And again, this is just an example, and we're gonna start with the ADC, and with with the programming today we should have covered the DAC, I2C, SPI, servo, and the LCD. So And as usual, we have to include the Arduino.h to support the board setup and configuration. I am creating two variables, sensor value that I will store the analog input read inside that, or into that variable. It's an integer. And I'm defining the sensor pin, which is the analog input pin, to pin 6. I just use the def because that really saves you some memory. It's really not really existing in the memory as a variable. It's just a def that will the compiler will replace that label with 6 all over your code during compiling. So that's a little difference about def and an actual variable. All right, so we will start with the initial setup function, which is the setup. And here I just wanted to create a quick message and print it to the console screen. So that tells me that, hey, the program just started and everything looks good. Okay, that's all we're going to do for now for the setup. And I move on to the loop function. And as you know, the loop function here will go in continuous loop as long as the controller, a microcontroller, is powered up. So it's basically like an infinite while loop. So what I did is in the beginning of the loop, I will read the analog value from the input, the analog input pin, which is sensor pin on pin 6. And I will assign that reading to sensor value. Now all I'm going to do is I'm going to print to the terminal just a label, and right after this I'm going to print that sensor value. I added 1 second delay to allow us to see the output and not just to drive the microcontroller crazy. Basically, it gives it a little break. Good. So as usual, we're going to go here and compile and build. And building should appear here and say success. Nice. And then I'm going to upload. As you hear that sound, that is the good sound. It means the board was switched to bootloader and uploaded the file, and then it's back to normal. Now if I switch to serial terminal, I am going to see a continuous output every second of the sensor value as we expect here. Now by looking at the board, I am going to move that joystick left and right, and let me get that here. So when I move it left, I basically ground the pin so it reads 0. Right, here it is. If I put it in the middle, it will go to almost to the middle, 500 something. If I move it all the way to the left, to the right, on the opposite, as you see, I'm going to read the full 1024. In this case, it's 1022, 21. Okay, so you can get the picture that the analog input is functioning. I can read the value. Now, if I move it a little slow to the left, you can see the value going down slowly, because again, that's a potentiometer and it's gonna read an analog output from the potentiometer as I move it. And basically, if you have a volume or if you have some type of sensitivity change, and that's what it is doing. So I'm going down 105, 73, 60, 39, and then I'll move it all the way to 0. I'll move it back again to the middle, and then I'll move the other way going up, and you can see now I can read, went up to a little sensitive here, so I'm reading 600, 90, 700, 20, 730, 50, 70, 80, and here I am going to 800. And as you can see, the analog input is really sensitive, and it's reading really good values all the way to the end, and here I am all the way in the end. Okay, so again, this here moves one way or the other to change the value on the output of the potentiometer that goes directly to the input, analog input on the microcontroller, and then you see that readings. Great. We finished working on the ADC project. I thought the next one I should use the LCD project, or work on the LCD project. For us to do that, you will notice that I need to add a library here to the Visual Studio Code, so it knows how to compile and use the LCD that comes with the Seeduino Xiao. So to do that, let's visit home, and from home let's look for library. Library, we need to search for U8X8 and press enter. This should come up with the UHG2 library. If you click on it, you can go here and just say, well, you're gonna have to find the latest release, of course, but then you can click on add to project, and this will add it to your current project that you have. We'll ask you select the project, and right now I have the Programming 101, and all this stuff you can leave it as is, and that's where you can click add. I already have it in my project, so I am not gonna click add. Let's close this now because we have it, we're done with this part. Let me quick show you the folder where your project is. So this is where my project is, the Seeduino Programming 101. You can see that your source file is in main.cpp, and if you have include like H files, you can put them here. Libraries we just added to support your hardware, you can look for it in the .pio folder under lib dibs, and then you will find the Seeduino inside there, and any library you need to add manually or you add it through the Visual Studio Code, you will find it here. So like we just added this library here, and I added this too for later, we're gonna use it. Going back to the code, as you see, we added this include file by adding the library to our project folder. I have here, this is create an object of the LCD with the input of 255, just to show that there's the reset. And I created an integer, and we'll play with that in a minute. This is just for the fun to play different numbers on the screen so we know what's happening. Okay, let's look at the setup. In the setup, we're gonna use the object for the LCD and use the begin, because this will initialize your LCD. Once you do that, you can set up the flip mode, and it's supposed to have a number from 1 to 3. I am not successful doing that yet, so I'm still figuring out what is missing, why it's not flipping, and I need to go into the data sheet for the LCD itself, but I will have another video based on that. Now you can print to the LCD in two different ways. You can set the cursor to where you want to start printing, which this has to be done at least once, and then you start printing to the screen, and it will just print either a print or a print line when you can go to the next line, and I will show you that. Or you can keep setting the cursor of the screen or the LCD to where you want to put your next character, so you can print in a specific location every time you want, and this will allow you to print stuff like menus or information on the screen that you don't lose the location for, or override. Okay, so this is it for setup. Let's look at the loop. You have options to select different fonts for the LCD, so you can select that, and if you hold the control, you see how the mouse changes to a hand, pointing hand. You click on it and it will take you to u8x8.h, and it will show you all the fonts that are available, and you can select one of them. As you see here, I have this one for now, which is just the default that I found, but you can also select any of these fonts, and you can play with them and see how it looks like. Good. So going back, you can set the cursor of the LCD to wherever you want to print your next character. However, what I'm doing now is printing a message with only print without returning to the next line, and then I'm printing an I, which is a variable of basically is going to go from 0 to 4, and this will allow me to print a different message every time I print this line here. So good, let's try it, compile it. Good, we can see here the success and then the close, so we're good. Let me upload it to the board. Great, as you see the success, so we're done. So let's look at the LCD. Okay, so as you can see, the LCD is printing, and new line is printed with a new sequence number. And the thing is, when it goes over the screen, the LCD, it comes back on top again, and it rolls over, and it comes back to the top. So something I found that if I keep doing this, the screen is not gonna like it and start printing this messy output on the LCD. So I think it's not a good idea to do that unless you keep track of what line you're printing on the screen, and make sure you clear it, or you start up on the top again. Good. So as we continue, I thought that I like show you how to work with the real-time clock, the RTC. For us to do that, there is a library that we have to include, PCF 8563. And for us to do that, I have to show you a couple of things. So I'm going to put the link to that library. However, I couldn't really determine which library it is directly from Visual Studio Code. So I went to this link here for the website where I know this is the actual library that I need to use, and I tested. I'm gonna add this link in my description. What we need to do is manually add this library to our project, as I mentioned early in the video. So we can go here to click onto the code and click on download zip file. When you click on that, it will ask you where do you want to download it, and I would download it somewhere wherever you need, but remember that we need to extract this library to the project folder. So I am extracting it to the project folder. So as you go to the project folder, we need to extract it to the .pio folder in your project, and libdips, which is I believe they call it for the library depends dips for your project. Seeduino, and here is the folder that I downloaded and extracted from that PCF 8563 library. You can always call it whatever you need, so you can get rid of the extra text. I would just call it PCF 8563. Any folder inside this Seeduino Xiao or Seeduino will be searched by the compiler to look for these dependables library. Good, so we go back to the code and we added that library. I have this object for the PCF 8563. This is how we can work with the real-time clock. And the wire, we need that library for the I2C. Again, we start by creating another object of the LCD with the reset value, so the microcontroller can or knows how to reset the LCD in the beginning. I added few variables here: year, month, date, hour, minute, second, so I can use that to load the time to the real time clock. And I have a sub function here, another function that will do that for me actually. In my setup, I call that setup time, and with that setup time, it will automatically load these values for now into my variables. And because I don't have any way to update the time at this point, so for the example, these are good, and it's a good start to see that real-time clock counting and changing the time. When I go back here, I initialize the screen, the LCD. So let's do that here. And also the flip mode, which I need to work on that. In here, I am going to init my I2C. Good. From here, I'm going to initialize the PCF, which is for the real-time clock, and I'm gonna stop the clock. This is a good thing if you want to modify anything in it. You can stop the clock and start the clock after. And as I mentioned, I'm going to use these variables to load and set the year, month, day, hour, minute, and second. And that's it for the setup. In my loop, so I am getting the time from the real-time clock. So the time is maintained continuously inside that chip, and the chip talks to the micro with an I2C, and as you get time from it, you load that time here into the time component. Again, setting up some font to the LCD, and then let's print the time by selecting the cursor where you want to start, and print, and then you select the cursor to the second line and do some more printing. So what we're printing on the first line, line number 0, is the year, month, day, year, right? And then on the second line, which is line number 1, I'm printing hour, minute, and second. Great, so let's see that working. Okay, as you see, after uploading the firmware to the microcontroller, the LCD is displaying the same counter as we initialized the variables, and it's counting up, so you can see it going up. It's been running for about 40 seconds now.